Welcome my dear student in Prep 3. Let's continue our session about Cartesian product. Today we will discuss part 3, which is the last part in this session. This part is about the Cartesian product of infinite sets and also of intervals. Okay, the Cartesian product of any two infinite sets also will be an infinite set. So if you have an infinite set X, for example, if X is the natural number or the integers or any infinite set, the Cartesian product also will be an infinite set. For example, if it's the natural number, I'll get the Cartesian product of n by n, natural number by itself. In this case, it will be all the ordered pairs in which the first and second projection belongs to this set, which is the natural number. By the same way, the integers or the rational number or the real number. Okay. So the Cartesian product of two infinite sets can be represented as an infinite extended surface for all sides. Okay. Here, for example, a small part of this surface. If you draw the x and y axis, all the plane is the Cartesian product of the two infinite sets, or the plane. But here we will take a small part of this plane. We will divide this plane into 4 parts or 4 quadrants. The first one here is the first quadrant. We call it the first quadrant. In the first quadrant, any point, the x projection of any point here will be positive, and also the y projection. Let's look at here. The x projection, it means the value of x here. In this part, the value of x is always positive, and the y projection, it means the value of y in this part. In this part of the axis, this value will be always positive. So in the first quadrant, the x and y projections both are positive. Let's move to the second quadrant. The second quadrant here, as you can notice, y is positive because this part is the positive part of y-axis, but x is negative, less than 0. So in the second quadrant, x is negative and y is positive. The third quadrant here, both of them are negative. Finally, in the fourth quadrant, x is positive. This is x, the part of positive x, and here y is negative. Okay, so now we can determine the part in which any given points locate. The first quadrant, if the two projections are positive. The second quadrant, if the x projection is negative and the y projection is positive. Third, if both of them are negative. And finally, fourth quadrant, if x is positive, y is negative. And you can notice that if you have one of the two projections is 0, it means that the point located at x or y axis. Okay, so if you have a point in which the first projection is 0, for example, 0 and 2, what does it mean? It means that the x projection is 0, so this point is on y-axis. Here, for example, this is the point located at y-axis. What about x-axis if the second projection is 0? So the first projection is whatever, for example, A. The second projection is 0. It means that this point is on x-axis. Okay, so if the first projection is 0, it means that the point is on y-axis. If the second projection is 0, it means that this point is on x-axis. Let's take an exercise here. Mention the quadrant or the axis on which each point lies. The first one, -3 and 5. The first projection here is negative. The second projection is positive. So in which quadrant? First is positive, second is negative. Okay, let's remember here we have x and y axis. This is the first the first quadrant, the second and third and fourth. Okay, here we have the first projection, or the x negative and y positive. Look at here x negative and y positive. So in the second quadrant, the second point here we have positive, x is positive and y is negative. So this is x positive, y is negative, so we are in the fourth. Both of them are negative, so this is the third quadrant. X is 0, so y-axis, both positive first. Okay, y is 0, so x-axis. Okay, it's very easy, but you should imagine this figure. First both positive, second negative positive, x and y, third negative negative, both of them in the third quadrant, both of the projections are negative, and fourth x is positive and y is negative. What about the Cartesian product of two intervals? Okay, if you want to get the Cartesian product of two intervals, in this case you will draw the first interval on the x-axis or the horizontal axis, and the second one on the on y-axis. Okay, so let's take an example. If x equals -2 and 1, y is 0 and 2. Find the region which expresses each of the following using the perpendicular coordinates of the Cartesian product r by r. Okay, x by x is -2 and 1. So I said the first, which is x, on the x-axis, -2 to 1. From here, on the x-axis, from -2 to 1. So I draw this region, and you should notice that this region can be extended up and or down. You can extend it up or down. Okay, so this is the first region. Let's continue. The second is also x, which is -2 and 1, but this time I'll draw it on the y-axis. From -2, this is -2 to 1, this is 1. So this is the second one. So where is the Cartesian product of x by x? This is the intersection of the two planes. Okay, the intersection of the two regions here. So this region, which have the two, this region which has these two colors. So this is x by x. What about x by y? Okay, x is -2 to 1 by the same way that like here. This is x, the first one. Where is y? Y 0 to 2, from 0 to 2 on y-axis. So from here, 0 to 2. This is the second. So where is the Cartesian product of x and y? X by y, where is it? The intersection region. Okay, the common region between the two intervals. This is. Okay, so here x by y. Okay, so if you have a Cartesian product between two intervals, we will draw the region of the first interval on x-axis and the second on y-axis. The intersection between the two regions is the Cartesian product of the two sets or of the two intervals. Okay, now show which of the following points belongs to x by y. This is x by y. Okay, this region is x by y, this region. Which of the points belongs to x by y and which are not? Okay, let's take the first one. Point 1 and 2. This is 1 and this is 2. This point of course belongs to x by y. What about 0 and -2? 0 here and -2. Of course, yes, it doesn't belong. 3 and -1. 3 and -1 doesn't belong. -2 and -2, this is -2 and -2 also doesn't belong to the Cartesian product of x by y. Okay, So the Cartesian product of two intervals is the intersection between the two intervals on the x and y axis, and any point outside this region is a point which is not belong to the Cartesian product of the two intervals. Okay, this lesson or this session was the last part of lesson 1. So next session we will start lesson 2. It's about relations and functions. Thank you very much for watching. I hope you have understand our session today. See you next session. Goodbye.